Watching channel Maths and Method Academy. In this video we are going to learn the basics of differentiation. You might have seen these formulae earlier. Rather, many students might have memorized these as well, but many of these students are still confused when it comes to the application of these formulae. That is, the given question will be differentiated with product rule, chain rule, plus minus rule, or quotient rule. How do we come to know which rule will be used when? We will try our best to clarify all your doubts related to the application of these formulae. Hopefully all your confusions will come to an end after watching this video. So let us start with the basic formula of differentiation, which is as follows. D by dx of x raised to power n is equal to n we will bring down and then subtract 1 from the power of x. So the differentiated form of x raised to power n is equal to n multiplied by x raised to power n minus 1. Now we will try to explain this formula with the help of some examples. Our first example is we will differentiate x raised to power 4 with respect to x. So what we will do here, in the similar way as it is shown in this formula, we will bring down 4 and we will subtract 1 from the power. So the differential of x raised to power 4 will be equal to 4 into x raised to power 3. Our next example is x raised to power 7, that is, we will try to differentiate x raised to power 7 with respect to x. So similarly, as we have done in the previous example, we will bring down the power x 7 multiplied with x raised to power 7 and then subtract 1 from the power. So our answer will be 7x raised to power 6. Let's try another one. Let us try x itself. So d differential of x with respect to x is equal to, we will apply same formula. This can be written as d by dx of x raised to power 1. We will apply the same formula. We will bring down the power, which is 1, and we will subtract 1 from the power itself. So 1 into x raised to power 1 minus 1, anything multiplied with 1 is the same number, and 1 minus 1 will be 0, and anything raised to power 0, any variable raised to power 0 is equal to 1. So the differential of d by dx of x is equal to 1. Let's try one more example. D by dx of x raised to power minus 4. Here this example includes negative power. Even in case of negative power, we will apply the same rule. We will bring down minus 4 and subtract 1 from the power. So the answer will be minus 4 into x raised to power minus 5. Let's try another negative number, negative variable with the negative power. D by dx of x raised to power minus 1. No difference, we will do it in the same way. Minus 1 into x raised to power minus 1, and we will reduce power by 1. So the answer is minus x raised to power minus 2. Now let's try some variable with the fractional power, like this example, d by dx of x raised to power 3 over 2. We will apply the same rule. We will bring down the power of x, which is 3 over 2, and then subtract 1 from its power. So the answer in this case will be 3 over 2 into x raised to power 1 over 2. Let's try one more example. D by dx of x raised to power 7 over 2. We will bring down the power, which is 7 over 2, and then subtract 1 from the power. So 7 over 2 minus 1. So the answer will be 7 over 2 into x raised to power 5 over 2. One more example, like if we try to differentiate square root of x, how it will be done. Square root of x can be written as x raised to power 1 over 2, and now we can apply the same formula, the basic formula, this one. 1 over 2 will bring down and then subtract 1 from the power. So it will be 1 over 2 x raised to power minus 1 over 2. This we can bring down to make it positive, into x raised to power 1 over 2. But we know that x raised to power 1 over 2 can be written as x square root. So the final answer will be 1 over 2 multiplied by square root of x. Almost all types of differentials are explained in above mentioned examples that are of the type x raised to power n. Now let us move on to the next formula, which is related to derivatives of sum of two functions. We will remove this one now and we will go to the next one. Okay, the formula related to the derivative of sum of two functions is d by dx of u plus v is equal to d by dx of u plus d by dx of v. So very simple, we have to differentiate both the functions one by one, where u and v are two functions. Can be functions of any variable, whichever is there at that time. Okay, so let's explain this formula with the help of some examples. Our first question in this case, differentiate x cube plus sin x with respect to x. So what we have to do in this case, x3 is there in place of u and sin x is there in place of v. So simply we will separate them, like we will write it d by dx of x cube plus d by dx of sin x. Okay, the differential of x3 is same thing we will do, like we will bring down the power 3 and subtract 1 from the power, plus differential of sin x is cos x, that we can see from here. So we will be writing it cos x. So our final answer will be 3x raised to power 2 plus cos x. Let's take another example. D by dx of 4 minus 5 sin x plus 3 log of x with the base e. This example is even in extended form where we have three functions. We can call them like 4 is the first one, minus 5 sin x is the second one, and plus 3 log of x with the base e is the third one. We will apply the same rule. We will write it like d by dx of 4 minus d by dx of 5 sin x plus d by dx of 3 log x. 4 is a constant and differential of any constant is equal to 0, minus if any constant is multiplying is one variable, so that constant can be taken out. So we can write it like minus 5 d by dx of sin x. In the case of differential of 3 log of x, we will do the same. We will take out 3 and we will write differential of log of x. Differential of sin x is cos x and the differential of log x is 1 over x. So our final answer is minus 5 cos x plus 3 over x. Now let us take another example. It is d by dx of 25 tangent of x minus 7 cosecant x plus 2 e raised to power x plus 6. In this example we have even 4 functions. So let us solve this one. We will write d by dx of 25 tangent x minus d by dx of 7 secant x plus d by dx of 2ex plus d by dx of 6. Again here we will take out 25 because it is multiply with the variable, so 25 is out of the differential, and we will write d by dx of 10x. Again 7 will be out, and d by dx of secant x plus again 2 is out, d by dx of ex, and differential of any constant, it is equal to 0. So we'll write 25. Differential of tangent x is secant square x minus 7. Differential of cosecant x is minus cosecant x, cot x, so minus minus will become plus, and we will write cosecant x cot x plus 2, and differential of ex is same as ex. So this is our final answer of this question. Now let's move on to the next formula, where we have to differentiate product of two functions. In this one we were differentiating sum of two functions. In the next one we are going to do the product of two functions. So the formula is like d by dx of u multiplied by v is equal to u into d by dx of v plus v d by dx of u. Again u and v are functions of x or whichever variable you are differentiating at that time. In this formula we multiply the first function with the derivative of the second and then we do the same for the other variables. So like what we do, we are writing u, then we are multiplying it with the derivative of b, and then we are writing v and we are multiplying with the derivative of u. Okay, let us go through some examples to understand this formula. D by dx of x cube multiplied by sin x, where you can say this is u and this one is v. So let's apply above mentioned formula. First we have to write u, which is x cube in this case, multiplied by d by dx of v, which is sin x in this case, plus we have to write v, which is sin x in this case, multiplied by d by dx of u, which is x cube in this case. Let us solve it further. So x cube, differential of sin x is cos x, plus sin x, differential of 3x is 3x, 3 minus 1, so the final answer is x cube cos x plus 3x square sin x. This is the final answer. Let's try another example to have further explanation of this formula. D by dx of ex multiply by cos x again. This ex is in place of u and this cos x is there in place of v. We have to write u first, which is ex, and then we have to multiply it with the differential of cos x, plus again we have to write v, which is cos x, and then multiply it with the differential of u, which is ex. Ex, the differential of cos x is minus sin x, plus cos x, and the differential of ex is ex. So the final answer is minus ex sin x plus ex cos x. Let's take another example. D by dx of x cube plus 1 into cos x. Okay, in this case this is u and this one is v. Okay, let's apply our formula. First we have to write u, which is x cube plus 1 multiply by dx of cos x, plus we have to write v, which is cos x, and then multiply it with the differential of u, which is x cube plus 1. Let us further simplify it. So x cube plus 1, differential of cos x is minus sin x, plus cos x differential of x cube is, we have to bring down 3 and then subtract 1 from the power, which will become 2 when we subtract from 3, and plus differential of 1 will be 0 as it is a constant. So we will have minus sin x or we can write it like minus x cube plus 1 into sin x plus 3x squared multiplied by cos x and this is our final answer of this question. Let's try a different type also. D by dx of x squared plus cos x into x squared minus tangent x. This is u and this function is v in this case. Let's apply our formula. First we will write u, which is x squared plus cos of x multiply by d by dx of v, which is x square minus tangent x in this case, then plus v, which is x squared minus tangent x in this case, and differential of u, which is x squared plus cos x in this case. So x squared plus cos x into differential of x squared is 2x and differential of tangent x is secant square x plus x squared minus tangent x. Differential of x squared is again 2x and differential of cos x is minus sin x. So this is our answer. Now we will move toward the composition of functions, formulas which are related to composition of functions, how it will be done. Sorry, function related to composition functions. Composition of functions. And we will explain it with the help of some examples. So our first example is d by dx of sine x raised to power 3. Here in this case, first we will differentiate sine x. First we will differentiate sine and then we will differentiate its angle as well. So it will be done as differential of sine x cube is cos x cube, and then we have to differentiate its angle as well, which is x3. So the final answer will be cos x cube into 3x raised to power 2. You can write it like 3x raised to power 2 into cos x raised to power 3. Let's take another example. D by dx of cos x raised to power 4 plus 6 is equal to differential of cos is minus sine x4 plus 6, and then we will differentiate its angle as well, which is x4 plus 6. It will be d by dx of x4 plus d by dx of 6. Minus sine x4 plus 6. Differential of d by x4 is 4x cube and differential of 6 is 0 because it is a constant. So our final answer is minus 4x cube multiplied by sine of x4 plus 6. Now we will go for another example so that we could have more clarity on this formula. Our next example is d by dx of cos log x. Okay, so differential of cos x is, cos is sine minus sine, so we will write minus sine of log x, and then we have to differentiate log x as well. Differential of log ex is 1 over x. So our final answer is minus sine log x over x. The next example is d by dx of sine 4x. Here we will differentiate twice, once because of power and then because of sine x as well. So this can be written as d by dx of sine x raised to power 4. Now we differentiate it. 4 sine x raised to power 4 minus 1 into differential of sine x. So the final answer is 4 sine cube x into differential of sine x is cos x. So this is our final answer. Now we move on to another rule which is called quotient rule, where we will be differentiating two expressions which are in the form of a quotient. So our formula in this case is d by dx of numerator over denominator is equal to d multiplied by differential of n minus n into differential of d over d square. Okay, let us explain this formula with the help of some examples. Our first example is d by dx of ex over sin x. Here we have ex as n and sin x as d. So let's apply this formula for the solution of this question. First we have to write d, which is sin x, multiplied by differential of n, which is ex in this case, minus we have to write n, which is ex, multiplied by differential of d, which is sin x in this case, over d square. D is sin x in this case. Let us simplify. Sin x, differential of ex is ex minus ex, differential of sin x, which is cos x, over sin square x. This is our answer of this question. Let's have one more example in this case. D by dx of x plus sin x over x plus cos x. Again, this is denominator, this one is numerator. Let's apply our formula. First we write d, which is x plus cos x, then differential of x plus sin x minus, you will write d, which is x plus sin x, and then differential of x plus cos x. Let us solve it. So x plus cos x into, first we have to differentiate x, the answer will be 1. Then we have to differentiate sin x, the answer will be cos x minus x plus sin x. Then we differentiate x, answer will be 1, and the differential of cos x is sin x. Sorry, you forgot to write here, over d square. D square is, d in this case is x plus cos x whole square, and that will also be here, x plus cos x whole square. So this was our final example. I have introduced almost all the basic rules of differentiation to you, hoping that you will be able to solve many questions that are given in your book. That's all for now. Until the next time, take care and bye.